In lesson 7.3, we learned about the Pythagorean theorem and some of the applications of it. And so first, we just want to state what the Pythagorean theorem is. It states in a right triangle, so this is in a right triangle, the sum, so we're adding things, of the squares, so squaring some things, of what are we squaring? The legs of the legs equals the square of the hypotenuse. Now, a lot of times we see this as a squared plus b squared equals c squared, and that's true, but it has to be in a right triangle, which we'll talk about some other lengths later to see if something is a right triangle or acute or obtuse. So in a right triangle, so you have to have a right triangle. If the legs are a and b and the hypotenuse is c, then we know that a squared plus b squared is equal to c squared. Now, in order to use the Pythagorean theorem, what we want to do is we want two of the things. So maybe we have both legs, but then sometimes we might have a leg and the hypotenuse, and we plug those in and we can solve for b. So just be careful to put the things in the right spots. Legs go in for a and b, and the hypotenuse goes in for c. So what we'll do is I'll do one of these examples, and you guys will do the rest for your assignment. So we have a right triangle. We have two sides, so we know that a squared plus b squared will equal c squared. In this case, we know a leg is 12. And I'm going to not use the miles right now, and I'll add that in at the end. So leg squared, 12 squared, plus the other leg squared, which is x squared, equals the hypotenuse squared. The hypotenuse is always across from the right angle. And then we do the math here. You may use a calculator if necessary. So 12 squared, it's 12 times 12, that's 144, plus x squared equals 13 squared, that is 169. And so we would subtract 144 from both sides. So the rest is just solving. We get x squared. This is 25. And then finally, we take the square root of both sides, and we get that x is 5. And remember, we are talking about a unit here, so this is 5 miles. Let's come down to number 5. Let's look at number 5. Number 5, once again, we do have a right triangle, so we know that leg squared plus leg squared will equal hypotenuse squared. I'm going to pull up the calculator for this one. And we have, one of our legs is 5.7, so 5.7 squared, plus another leg, which is 9.5 squared, is equal to the hypotenuse squared. So let's figure these things out. 5.7 squared is 32.49. 9.5 squared is 90.25. We're going to add those together. So 90.25 plus 32.49. That is 122.74 equals x squared. And now what we need to do is take the square root of both sides. And so in the calculator, we will do the square root of 122.74. And we get x equals 11 point, let's go up to our directions, round your answers to the nearest tenth. So 11.1 centimeters. So that's using the Pythagorean theorem. Down here, these directions still. For 8 and 9, refer to the Pythagorean theorem. It says find the missing side of each right triangle. Side C is the hypotenuse, sides A and B are the legs. Round your answer to the nearest tenth if necessary. So let's see, we know that A squared plus B squared equals C squared because A and B are legs and C is the hypotenuse. So we can plug in. Looks like we don't know A, so A squared equals B squared, which is 8 squared. So plus 8 squared equals 10 squared. Not equals, so this is 64 equals 100. Subtract 64 from both sides. We'll come up here. We get A squared equals 100 minus 64 is 36. And we take the square root of that. And we get A is equal to 6, and the units is in miles. So in that one, it didn't draw a triangle for us, but it gave us the information we needed. Okay, the next part of this lesson, I'm just going to scroll up here. This is a corollary to the Pythagorean theorem. In fact, it's more of a corollary to the converse of the Pythagorean theorem, but here's what we're going to do here. If we're given 3 lengths, we can determine, first of all, if it even forms a triangle. We learned that a while back. The 2 smaller sides must add up to be larger than the third side, which in all of these examples they do. So in these examples, we're assuming that it's a triangle, and we want to determine what type it is. And so all you do is you take C squared, which is the longest side squared, and we also find A squared and B squared and add those together. Those are the 2 shorter sides. Now this isn't just longest side and the 2 shorter sides, and then we compare them. And that's what this part says down here. If the longest side squared is greater, so if we put a greater than in this blank, then it's, I have this backwards. If it's greater, this is an obtuse triangle. So make sure you change that on your paper. If they're equal, then it's a right triangle, and if the longest side squared is less than the sum, it is an acute triangle. All right, so make sure you definitely fix that. And so we'll just grab a couple examples here and figure those out. So state if the 3 lengths form an acute, obtuse, or right triangle. So what we do is we start with the longest side squared. So that's 10 squared. And we're going to compare that to the sum of the other 2 squared. Add those together and we get 127. So the 100 is less than, and so this is an acute triangle. All right, let's come to 14 and check this one out. Let's see what happens with number 14. We're going to take our longest side squared. We're going to need a calculator for this one. Longest side squared. We're going to put a little box to compare these. We're going to compare them to 36 squared plus 10.5 squared. Let's figure out what all these things are using our calculator. So 37.5 squared. That is 1,406.25. 36 squared is 1,296. And 10.5 squared is 110.25. Well, let's add those 2 on the right together. That's 1,296 plus 110.25. And we actually get the exact same thing. Well, what type of triangle is it? If we get the exact same thing, it is a right triangle. So right triangle. Okay, so you can finish those up using that same process. And the last part of this lesson, we're going to use Pythagorean theorem to help us find areas of triangles. So we know that the area of a triangle is 1/2 base times height. And we also know that base and height are always perpendicular. Always perpendicular. So in some of these, we don't have both the base and height. We need to find them. So we'll take a look at number 19. 19, we want to find the area. So we want 1/2 base times height. Well, we have a base here is 6. However, we don't have the height. 12 is not the height because they are not perpendicular. So can we find the height? Certainly. We can use the Pythagorean theorem. So to the side here, we'll do 6 squared plus the height squared equals 12. 6 plus 8 squared equals 144. Sorry, equals 12 squared. I didn't write the squared there. Subtract 36 from both sides. And we get, 108. And then we take the square root of both sides. Now, I think in the directions, which I did not read aloud, mentioned something about this. Find the area of each triangle, round intermediate values to the nearest tenth. So an intermediate value is what we're trying to, like in between stage. Use the rounded values to calculate the next value. Round your final answer also to the nearest tenth. So we need the square root of 108. So we'll type that in our calculator. We're going to the nearest tenth. Well, I didn't type that in right. Square root of 108, we get 10.4. And now we can plug that into our formula. Our height is 10.4. And so area equals 1/2, which I'll just put in 0.5, times 6 times 10.4. And our area is 31.2. No units are mentioned, so we'll just put units squared. So 2021 will be similar to that. Let's look at 22. 22 and 24 will be similar, and you can also figure out 23 similarly. So here, these sides are congruent, which means these angles are congruent, which means it's isosceles, which also means this whole length here has to be 8. So our whole base is 8, but we still need the height. Well, if we take a look at just one side here, we have a right triangle. And so we can use Pythagorean theorem. So we can say 4 squared, that's one of the legs, plus h squared equals the hypotenuse, which is 9 squared, and we just work our way through solving this for h. So h squared equals 81 minus 16 is 65. We take the square root of both sides. Square root of 65 is 8.1, because we're supposed to round to the nearest tenth. Now that we have 8.1, we can find the area. Area equals 1/2 base times height. In this case, it's 1/2. Our base of the entire triangle is 8, and the height is 8.1. We'll multiply that out, and we get half times 8 times 8.1, and the area is 32.4 units squared. So use those few examples to help you finish 20, 21, 23, and 24.